Solving polynomial equations is very similar to how we've solved quadratic equations in the past. And this makes sense since a quadratic is a specific type of polynomial. As we all know, one method of solving is factoring. And we learned from our last learning target how to find the solutions given factored form, but today I want you to be able to actually factor a polynomial. So what I would like you to do is see if you can solve this quadratic by factoring. This right here. I want you to solve it by factoring. And at this time, if you want to pause the video, you can take a few minutes and try to solve it. So the first thing you should notice is it's not set equal to 0. Anytime you solve a polynomial, the first thing I want you to do is set it equal to 0 and write it in standard form. So when I move that term 7x to the other side, make it negative, and I'm going to stick it between the squared term and the constant. When I factor this, I know the a value is 1, so I know that's going to be x and x. At this point, I need to think of two numbers. They need to have a product of 10, meaning they multiply to be 10, and a sum of negative 7. So if they multiply to be positive, but they add to be negative, they're both negative. So what two numbers multiply to be 10 but combine to be 7? That answer is 2 and 5. Now at this point, you should know the two answers because this is factored form. And to get your zeros from factored form, you use the zero product property. Take each factor, set them equal to 0, and once you solve these two equations, you come up with x equals 2 and x equals 5. Okay? Now before I extend this concept to greater degree polynomials, I first need to show you some special factoring patterns. So we're going to learn how to factor the sum and the difference of cubes. Now this may not make sense at first, but when I show you some examples, it'll hopefully make sense. And what I'd like you to do is write this down as I write it down. So first we'll do the sum of two cubes. So if I have a cubed plus b cubed, that's the sum of two cubes. Here's how you factor it. A plus b times a squared minus ab plus b squared. Again, this may not make sense now, but wait till we do some examples. I'll refer back to it as we do examples. This one is obviously the difference of two cubes. So when we factor that, it'll be a minus b, and then a squared plus ab plus b squared. And just like it's important for you to learn the perfect squares, like 4, 9, 16, 25, 36, and so on, there's also some perfect cubes that you need to memorize. Okay, so perfect cubes are numbers when you multiply them by themselves 3 times instead of twice. So like 1 cubed means 1 times 1 times 1, and you get 1. 2 cubed means 2 times 2 times 2, and you get 8. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. and 6 cubed is 216. I would stop here. These are 6 perfect cubes that you ought to be very familiar with. When you see these, you need to identify those as a perfect cube. So take some time. If you need to pause the video to write this down for your notes, that's fine. But let's move on to do some examples. Example 1. This is a difference of 2 cubes. We know that the cubed root of x is, or the cubed root of x cubed is x, and the cubed root of 27 is 3. So if I apply that rule that I just showed you previously, the difference of 2 cubes, I'll start by writing x minus 3. So if you refer back to the pattern I showed you on the previous slide, x is kind of like your a, and 3 is like your b. So then when I finish this out, it says a squared, so I'll write x squared. Then it says plus ab, so that'll be plus 3x. And then it says plus b squared, which would make it 9. Okay? So from here, this quadratic factor, this cannot be factored any further. In fact, it actually has 2 imaginary solutions. Okay? So what we're going to do for that is use your Algebra 2 program on your calculator. However, this first one's pretty easy to solve. If you set x minus 3 equal to 0, you would add 3 and get x equals 3. For the quadratic part, you need to go to your calculator, to the Algebra 2 program, and select quad, a equals 1, b equals 3, and c equals 9. If you type that in, the 2 answers it's going to give you is x equals -3 plus or minus 3i square root of 3 over 2. These are your other 2 answers. And notice the reason I said other 2 answers is because of the plus or minus. That makes it 2 different imaginary solutions. So you have 1 real solution here and 2 imaginary solutions here. And we got those from using the Algebra 2 program on the calculator. Let's do another example kind of like it. This one is the sum of 2 cubes. So first, we take the cubed root of the first term, and that's going to be 3x. And then the cubed root of 1 is just 1. And so the 3x is like your a, and the 1 is your b. So first it's a squared. So that's going to give me 9x squared. Then minus ab, so 3x times 1 is 3x. And then it says plus b squared, so 1 squared is still 1. So from here, if I take 3x plus 1 equals 0, the way I would solve it is subtract 1 first, and then divide by 3. So I would get negative 1/3. The next one is a quadratic that cannot be factored. I'll go to the calculator, the Algebra 2 program. A equals 9, b equals -3, and c equals 1. When you enter that into your program, you get the other 2 imaginary answers are x equals 1 plus or minus I square root of 3 all over 6. Okay. So these 2 examples are going to be just like numbers 1 through 4 on tonight's homework assignment. So you can refer back to these and those special patterns I showed you. Now, numbers 9 through 14 on your homework are a little bit different type of polynomial to factor. you will notice that these equations are in the form x to the fourth plus bx squared plus c. And to factor these, follow the same rules as if you were factoring quadratics that we've done. The only difference is that instead of doing x and x like this, you're just going to use x squared, because in order to get your x to the fourth, you do x squared times x squared. But the same rules apply. To get your c value, you need two numbers that have a product of c and a sum of b. That's the only difference. Okay? So let's do a couple examples like this. If you need to take more time to write that down, you may pause the video. First example I want to do is x to the fourth minus 10x squared plus 9. Okay? So I told you to factor this. We're going to start with x squared. So I need two numbers that have a product of 9, positive 9, and a sum of negative 10. So how can I multiply two numbers and get positive, yet they add to be negative? And I hope by now you're getting that it's minus minus. So what two numbers multiply to be 9, but combine to be 10? 1 and 9. Okay? Now from here is where it's a little bit different, because if I were to take this factor and set it equal to 0, I would add 1, but I don't get x equals 1. I get x squared equals 1. So I need to take this one more step and undo squared by taking square root of both sides. The one thing I don't want you to forget, when you solve by taking square roots, you get plus or minus, and the square root of 1 is 1. Same thing with this one. Add 9 to both sides, take the square root, and x equals plus or minus 3. So you actually have 4 answers here. You have 1, negative 1, 3, and negative 3. I don't care if you want to write it with the plus or minus or split it out. Either way, I just want you to understand that plus or minus represents two different answers. Let's do another example kind of like this. X to the fourth plus 3x squared minus 4 equals 0. So again, it follows that pattern of 4, 2, constant. So we can start by setting it up x squared. But now look, we need two numbers that have a product of negative 4 and a sum of 3. So how can two numbers multiply to be negative? Well, it has to be one positive, one negative. That's the only way you can get a product of a negative number. So how can I get a product of negative 4, but those numbers add to be 3? Okay, well, my factors of 4 are 1 and 4 and 2 and 2. Obviously, the 1 and 4 combination is what I will use to get 3. But it matters which is positive and which is negative. If I want to end up getting a positive 3, I need to do positive 4, negative 1. Because 4 minus 1 is 3. But I'm not done solving. All I've done is factored it. To solve, I set each factor equal to 0. Okay? Now the reason this one's a little bit different is, now watch. When I subtract 4 from both sides, I get negative 4. And when I try to take the square root, you can't take the square root of a negative, so you have to factor out the I. And then the square root of 4 is 2, so I get plus or minus 2I for this one. And then over here, we've already done this one in the last example. X equals plus or minus 1. So if you want to split it out into your 4 individual answers, 2I, negative 2I, 1, negative 1. And that's that. There's one more type of problem that you will see in tonight's homework. And that's like numbers 19 through 22. It says to solve by graphing, and I want you to use your calculator here. But the way you do this is the same as when you've done any solving by graphing. You put the function into y equals, well, hold on. To solve by graphing, first, don't forget to set equal to 0. Don't forget that. Then, after you do that, enter into y equals on your calculator. Okay? And graph it. So set it equal to 0, put it into y equals, and press graph. Now where on the graph represents your solutions? That's going to be your zeros or your x-intercepts. Okay? And the way you calculate anything from a graph on your calculator is press, who knows it? Say it before I write it. Second trace. Second trace. And we're going to choose number 2, which is zeros. Okay? From here, it's going to ask you for left bound, right bound, and then guess. And after you do this with your cursor, each time hit enter between them. And then you're going to repeat this process. Repeat steps 3 and 4 for each x-intercept. Alright? So this is how you solve by graphing. Now the trickiest part of this is going to be this step right here for most of you. Because you've got to understand that when it says left and right, it's left and right of the point you're trying to find. Okay? So let me just show you this. If you have a graph and it looks something like, you know, if your line's going up this way and then down that way. That was really bad. Up this way, down that way. Okay? Well, if you're trying to find this 0 right here, the left side of that point, that red dot, the left side is down below it. And the right side is above it. Okay? But then, when you do it again to find this 0, it changes. Left will be above and right will be below. Because to the left of this point is, the graph exists to the left of that point above the x-axis. Now, what if that changes and now your graph is going the opposite direction? Well, again, it's always relative to the point you're trying to find. So to the left So to the left of that point is above, and to the right of that point is below. In the same way, over here, to the left of that point is below, and to the right is above. So move your cursor according to the left and to the right of the point you're trying to find. And then hit enter for guess, and it should tell you that 0. Alright? I'd like to do one example and then I'll be done. We're going to do number 20 from your homework page. Okay? And what that says is 36x cubed plus 6x squared equals 9x. Now if you reference the steps I had on the previous slide, the first step is to set it equal to 0. So that's going to be 36x cubed plus 6x squared minus 9x equals 0. From this point, I want you to put it into your calculator, into y equals, and then I want you to press graph, and after doing some window adjustment, hopefully you will see a line that sort of resembles this. Okay? Something like that. So if you're going to solve this by graphing, I want you to realize that there's 3 solutions. There's 3 different x-intercepts. Okay? Here's the first one, here's the second, and here's the third. So to find those points, you got to do it one at a time. Press second trace, option 2 for 0, and we'll start on the far left. Okay? So if I'm going to find the 0, the far left term, the left bound will be below, and the right bound will be above, and then hit enter to guess. And your 0, or your solution for that one point there, is negative 0.59 about. Okay? Now, press second trace again. Only this time we'll find the middle 0. So when it says left bound, the left bound of that middle 0 is above, and the right bound is below. And when you hit enter for guess, you will notice that that one is 0. And finally, to get the last one, the right side, press second trace, and option 2, which is 0. And when it asks for left bound, you want your cursor below, press enter. Then it says right bound, your cursor needs to be above, press enter. Then it says guess, press enter one more time, and hopefully you're getting something about 0.42. That's how you solve by graphing. Now, your assignment then for this homework is 5-3 practice, which is page 127 from your workbook pages that we tore out. And I want you to do numbers 1 through 4 and 9 through 14. And this is on YouTube, okay? And you can go to the video at home and watch it anytime you want. Thank you, and I'll see you soon.